Hi everyone, welcome to our session. My name is Madoka.
And hi, I'm Vishesh. So I guess before we kind of kick off, let's just do some intros.
Yeah. Hi, I'm Madoka Chiyoda, and I'm a software engineer at Microsoft Japan. I am still learning English, so my English is not good enough now yet, but I try my best. I love C# and Visual Studio. Before joining Microsoft, I had been a mobile app developer using Xamarin and Azure. I have 44,000 followers on Twitter at Tomado account. I am an engineer, not only an engineer, but also a manga artist. This is one of my manga works. I always paint a picture with Surface Pro and Surface Pen, and this is also my manga. And I usually draw manga about technologies. For example, I have some manga series in Japanese, and this is one of them. This manga series shows how to create voice assistant apps using Azure Functions. Yeah.
Awesome. Whereas on my side, I'm just an engineer, and that's all I do. Fortunately or unfortunately, I don't know. And I have a couple of followers, so if you guys want some more, feel free. Yeah. So again, welcome to our session, and I guess, both of us will kind of switch between different parts of it, but we'll kind of kick off with understanding what speech or analyzing speech really looks like in the real world when we're building software. What does that mean? Different elements of that sort of aspect as well, so thinking about recognition and synthesis and translation, intent detection and so forth. And then we'll hopefully have a few code demos, and then we'll sort of look into what's happening out there today. So if you think about all the devices, I've got an Alexa Echo Dot here, Madoka's got Google Home here. So we'll try and demonstrate some of the, I guess, samples that we've been working on, and some of the interesting scenarios that you can sort of enable off the back of it as well. So let's see how we kind of end up. There's a lot of stuff, but we'll kind of share between both of us and see how far it takes. If you think about sort of the communication channels today, what we've got here is a bunch of different platforms and a bunch of different, messaging apps as well. Whenever I go to a conference and bring this slide up, I often see someone with all those apps installed. Again, you don't have to tell me right now. You can come and talk to me later on. No prizes, but I'll judge. The other part really is that beyond these messaging apps and platforms, you're also looking at these devices and form factors that don't really have that flexibility of keyboard and mouse that we've used to for our existing computing devices and so forth. And at the same time, when you think about your house or your pathways and wherever you're kind of in the office as well these days, you've got these devices kind of hidden everywhere with a microphone potentially on top of them as well. So all these sensors enable an experience where stuff is getting more invisible. You have to interact with it through voice, and actually some people prefer it as well. I think I was watching one of the sessions on Monday, and they said that one of the speakers said that she's had her house fully voice enabled for the last 15 years, and I think that story will become more common over the years as well as these devices become more cheaper to install and aggregate across different environments. At the same time, I guess you'll notice how there's been a bit of a revolution across speech itself, right? So you've got breakthroughs that are taking place, with higher accuracy than actual transcription done by humans themselves. And this is a stat from 2017 where that was the human error rate that we kind of achieved with one of our algorithms. And if you kind of keep progressing on this journey, I mean, that accuracy will get better over time regardless of how fast or slow our commodity devices move. And what we've done is over the last sort of 4 to 5 years, we've taken a bunch of that research that was happening that took place for the last 15 or 20 years and really encapsulated some of that research into some products as well. One of them that we announced about 2 years or 3 years ago was the sort of speech services, which we've now consolidated under a single umbrella. And at Microsoft, it's really about helping you kind of get that access by just calling an API and getting access to all of those, amazing richness of sort of speech analysis that we've got behind the scenes. And as I said earlier in my introduction as well, when you think about speech, there are multiple aspects of it. And about 4 of them, for example, are listed on the slide, where you start by understanding, how do you go from speech to text, simple transcription, but then about synthesis as well, from text to speech. But then as we move forward in this journey, every brand or every company, organization wants to kind of bring their own personality into that, speech synthesis as well. So we look at how that's being enabled. At the same time, translation is a big part of it as well, where we want to really think about how we can move beyond just using statistical models to actually neural machine translation as well, which is more popularly known as machine translation, to help us translate some of that information in near real time. And then lastly, of course, you want to reduce that latency, right? So you don't want to go through this massive phase of, first of all, getting something from speech to text, translating it, and then finally getting the intent out of it. So we'll look at all those different aspects. And the one that's probably been the most popular, just because of the amount of research and availability of training data set, is recognition, where you can use your spoken audio, train them against baseline models, and then be able to kind of derive the exact transcription that's required for each of those inputs that you sort of throw into it. And again, it's a journey. It's not perfect, only 28 languages and dialects. So we don't have a whole lot of information out there, which is pretty standard across all vendors. But it's just that sort of, I guess, step-by-step approach of capturing the data first and then helping train across it. The other part also is just having quick access to it. As I said earlier, all of this stuff is just an API call away. So we'll see a bit of that in action just about now on how quickly it is to set all of that up. So if I quickly move over to my Azure portal, all I've done is really gone to the resource page, and I just quickly search for speech. And under speech, what we've done is, this is under preview right now, but in the next couple of weeks, we'll be sort of launching this to GA as well. But effectively, it's just one API key that you create, and you can use it across all the different elements of search as speech, as I was talking about it. So it works with recognition and synthesis and so forth. So once I've created that service, I won't spend time doing that. I've already got one created. So I'll grab the keys from the portal and simply, for example, go to a sample. All right, okay. All right, is it better now? Oh, theme, all right.
And now it makes you uncool, but
it's okay.
it wasn't the time.
It was never meant to be there forever anyway. There we go. Jazz hands, come on. Yes. Success. All right, there we go. If you look at this code really there quickly, what I've got is a simple recognize speech method, which effectively uses the SDK, and all I'm doing is literally writing this one line of code, which says, hey, recognizer, go and recognize this speech input that's coming from my mic. And that's all there is to it. So let's quickly try and run this sample. Even though I've switched my themes, hopefully everything works. It's not something I can blame if it doesn't work. But let's see if this works. OK. So it's good enough. There are some interesting elements to it where, I don't know if it's visible. I'll just quickly zoom in again. Some of the interesting elements being that a lot of it worked because there's no background noise here. There are no acoustics involved. Whatever I'm speaking is fairly understandable English because I'm being loud enough about it as well. So a lot of those nuances we'll talk about how kind of you can work through them as well. But if you look at it, it's as simple as making an API call, and right now I've just sort of said something that was less than 15 seconds, fairly easy to transcribe. But it didn't take more than, say, half a second to do that specific job itself. But more common scenarios that we look at is how can you recognize speech continuously? And we usually see that scenario when you're talking about call centers, for example, right? Where, for example, you might want to, you've got a lot of files transcribed and say, or not transcribed, a lot of call recordings, and you just want to transcribe them over time. And not just that, you think about how do you, derive intents from them as well. But again, in this case, I'm just simply using the same SDK, which is the Cognitive Services Speech SDK. And all it took me to kind of get that working was effectively just use this method, which is create speech recognizer with file input. And if we dive into it, you can clearly see they've got a lot of different options as well, where you can use file inputs, you can use streams, and you can use different set of languages and so forth as well. So there's a lot of flexibility. And again, it's all enabled through webhooks, so you can have a continuous stream as well, and you can do intermediary responses as well from those files. So let's quickly look at what this looks like. I've got a simple, actually, let me just quickly stop this and show you what the actual file looks like. So if I just quickly play this, hopefully sounds good.
What's the weather like?
So it just says, what's the weather like? Nothing exciting in there. So I'll just quickly now run this sample as well and show you how different inputs can kind of lead to the similar conclusion as well. So as you see, fairly easy, what's the weather like? And it gives you the duration and some offset values as well. So pretty simple there. Cool. And now if let's go back. Now, again, a lot of that simple transcription is easy because the recording was in American English, and again, my voice was loud enough for the computer to recognize. But things get more interesting when you're talking about, certain noise conditions, when you're inside a factory environment, for example, right? When you're kind of got different accents at play, you've got, speech modulation happening, or you've got different languages as well, different features for your language as well, where perhaps you might have a unique vocabulary specifically for the domain you're working in. And it gets even more interesting when you're working with things like these, dinosaurs. Does anyone know what this one's what type of thing this is? That's right. So imagine how Stegosaurus would work when you're trying to, transcribe something. So let's go back to my previous sample real quick for a sec and see if that works. All right. So I'll just use a standard recognize speech function that I've got there, which effectively takes a slab of the first 15 seconds. Stegosaurus. OK, so that worked. That's good. Now, what is also interesting is if you go into some of the more complex keywords, which look a little bit like, let me find it. There we go. So if you've got a vocabulary that looks like that, where you're talking not just about Stegosaurus, but you're talking about some of the other complex words and alphabets and vocabulary and whatever else there is to it, you'll have to kind of take into account what are the different elements at play. So for that, there is another one of these services, which is called the custom speech service that's kind of allows you to build these models and kind of adapt them to a specific data set. So in my case, what I've simply got here is a very basic data set that looks like, come on, there we go, I think it's that one. So I'll just So in my case, I've got these WAV files, and then I've also got some transcription data as well along with it. So each of these WAV files are saying something very specific. So when I send all of this training data over to this service, it then creates a model for me on top of which I can further enhance, build acoustic models, language models, and then finally expose it as an endpoint as well if I like to do. So again, very easy plug-and-play, API-based or portal-based experience. And once I've got that stuff going as well, I can start trying some more complex sort of sentences as well. So maybe if I try and go back to my initial first method, which was just simply recognizing speech, and I said, hey, can you recognize Stegosaurus? OK, so as you can see, if the sentence gets a little bit more complex, it's not able to pick it anymore. If I just zoom in as well so people can see at the back, it's not really able to recognize that part of the speech. But then if I take my new model that I've custom built on top of custom speech and use the endpoint from there, I can actually go in there and quickly grab that model, specify the subscription keys and my training dataset ID here, this one. What you'll notice is that it's using the same SDK, and all I've done is I've just said recognize async with that specific deployment ID that I've defined, that I've got from the custom speech portal itself. So let's quickly run this as well and see if that works. Hey, can you recognize Stegosaurus? There we go. So it was, I wish I could take credit. I didn't do anything. Yeah, I call the API, new developers. So there you go. So as you can see, it was fairly straightforward in the sense of how it worked, even with complex sort of structures. And you can sort of go as complex as you want as well in that scenario. One of the other features is, as I said, acoustic models as well. Now, again, we don't have a lot of background noise here, so there's no easy way of demonstrating that. But you can effectively upload information that has models or that has recordings of environments such as factories and so forth as well, with some of their transcriptions as well. So you spend a bit of an effort for a week or two, do some recordings, transcribe them manually, and then upload that training data set over here so the model really understands how that all works, to then help you get the right kind of information through as well. Now, so far we've talked about both recognition and building custom models for recognition as well. The other one's also quite interesting, which is synthesis, right? So if you think about how do you go from text to speech, and again, there are complexities to it as well, because you might want to improve accessibility. In Nigel's session yesterday, he showed the Seeing AI app that's on iPhones, where people with certain special abilities have to use a certain type of voice modulation as well to fully understand or grasp what's happening. At the same time, you've got scenarios where you're multitasking as well. The most classic one being, driving a car or walking around the house and so forth as well. And then you think about you want to, use multiple modes and have different aspects to them as well, because again, different people learn in different ways in different environments as well. And the last one, of course, being a little bit more interesting with a lot of push around marketing and brand awareness and being able to relate to a specific brand through their voice as well is quite interesting. So in the last sort of, I guess, couple of years or so, now you've got about 80 different voices across 48 different languages as well that you can use through the custom service as well that you've got. But one thing I'd like to highlight is that this hasn't happened in the last couple of years, as I was saying earlier, right? If you think about just a Skype translator app that you can now use today quite easily, and it's quite available as well, it took about sort of 25 years or so to kind of get there. So it takes a while to get all this research into just an API format. But now, again, as I said with some of the other aspects of speech as well, you get easy access to this stuff by just getting an API call as well. In the past, we were using the statistical-based model, but now we've kind of upgraded that over to machine translation based on neural networks as well. So it's got a little bit more accuracy. I think we're looking at about 70% in some of the scenarios that sort of I've looked at personally as well. So it's really cool. Now let's try and do a quick demo. And I'll also probably ask Madoka's help for one of them. She's okay to jump as well. So what I'll do is I'll quickly start off with one of the samples. And then, let me get to the right place. Cool. So one of the interesting problems that I faced was some of the libraries, like if you want to play back something over the machine, you need .NET Framework for it, which kind of sucks, but it is .NET Framework. So now what I'm using is the same sort of speech SDK. Along with that, I've just defined a couple of sort of variables here, one of them being what's the language that the input will have and what's the output language. So let's start with the classic, normal English to American English sort of a transcription and see if that works. Hey, how's it going?
Hey, how's it going?
Okay, that's fine, nothing fancy there. So what I did was I was speaking in English, it translates into English, but with a specific voice persona, which is called Jessa in this case. So once I've used that sample, we can go into something more, hopefully, unique and impressive, and see how that works. Now we'll have to trust whatever Madoka says, because, all right, there we go. Let's see if that works.
こんにちは. Yeah.
Okay, that was easy.
Yeah, こんにちは means hello, and it is correct, I guess.
Okay. Do you have a more complex sentence as well? Let's try that.
今日のシドニーの天気は何ですか?
What
Yeah.
is the weather like in Sydney today?
Cool.
Yeah, it's
There we
cool.
go.
Yeah, it's correct.
And I don't know if you noticed the subtle reference there. There was a Sydney accent behind the scenes, so I could really feel the Sydney in the voice there.
Sydney or Melbourne?
So those were a couple of examples, but again, you can do the same thing with Japanese as well if you like, and again, you get a similar response. But as I said earlier, all I was doing was defining these two variables, and then from that point on, I just had to call this API, and whenever there's an intermediary response available, I grab that. Otherwise, I just wait for the final translation, which then helps me transmit that using the sound player API that's pretty standard across .NET Framework anyway. So nothing really fancy. Now, I guess the last part of it is, thank you, Madoka. Now, the last part of it is intent detection, where we've talked about multiple elements from recognition to synthesis and building custom models and translation. Now, intents become a lot more interesting because in a lot of scenarios, you're not just trying to transcribe something, especially if it's interacting with an actual human on the other side. You want to also derive some actions behind them as well. And what I mean by intent detection really is as simple as that. If you've got some piece of code somewhere, all I'm looking to do is execute that function with a couple of variables being, prerequisites to execute that. That's all there is to it. So in this case, find Oberoi becomes my intent, and my entities are those two. So again, let's try and do a quick, whiz through this demo as well and see how easy or difficult it could be to set that up. So the first thing I do is just go in and log into my LUIS portal. Again, LUIS is a natural language processing engine, or more popularly known as NLP. And in here, you can build models. So if any of you came to my session yesterday, I sort of talked about this in a much more longer length about what it all does. But in this case, I've got a very, very simple model that has got two intents. One of them is about greeting someone, and the other one is about finding the closest donburi that I can go and grab some lunch from. So those are my two intents. And if you were to see that in action, all I have to do is use that similar API endpoint. And when I say hello, it grabs that as a greeting intent with the score of something and gives me a sentiment analysis, a score as well at the bottom, if you can see there. So if I take the same model and sort of try to use it with my speech elements as well, all I have to do is probably go back to my main program, comment out the right one, which is the intent recognition with microphone that I've got set up there. And all I had to do was use the similar set of speech factory setup, add in my subscription ID, and from there on, I'm just using my LUIS model, defining what my different intents are, because maybe I want to assign an ID that relates to some actionable outcome towards the other side of it. And similarly call the recognize async method as well. That will then give me the response back. So let's do a quick run of that. Hey, can you find me a donburi around? Cool. So again, as you can see, it was fairly easy, but in this case, it transcribed my voice, but it also found out what the intent was and gave me a sentiment score all in sort of one API call, which is a little bit more powerful than just sort of doing a very linear, recursive call to multiple services as well, if that's. It's basically based on a bunch of data set that we've got, and the sentiment, if it's closer to 1, it's positive. If it's closer to 0, it is negative. But it's just based on a bunch of training data set that we've got over the years of doing research and so forth. Cool. And so as we kind of, I guess, mature towards some of these scenarios, and hopefully you got a better sense of, what are the different elements you need to think about. One of the other, I guess, important thing is also thinking about how you can do this in batch for your training data sets as well. So far in the last sort of 20 minutes or so, we've looked at different elements of what speech analysis looks like, but we also need to think about how you kind of deploy them into production as well. And so, building custom models, training the acoustics that are part of your environments are equally important. And so, doing a lot of the batch transcription sort of helps with that. But now, with that, I'd like to hand it over to Madoka, who'll talk about smart speakers.
Yeah.
Oh, yeah.
Thank you. Thank you. I'll talk about. あれ? すいません。
Let's see. There we go.
Thank you. Thank you. I'll talk about the first step of smart speakers, and then next I'll talk about Google Home and Azure Functions. First, I'd like to talk about why I started a smart speaker. I love my grandmother, but she has aged eyes and difficult to read. She can't even look at the TV screen and can't read the words. And so I bought a smart speaker for her. It reads news and cooking recipes so she can understand him. She looked very happy, so I'm also really happy. By the way, what is a smart speaker? I'm asking its definition, and I want to make it clear. It's a wireless speaker with AI assistant. A smart speaker is a type of wireless speaker and voice command device with an integrated virtual assistant that offers interactive actions and hands-free activation. Now, there are so many kinds of smart speakers all over the world. The first most popular smart speaker devices and platforms, and the first was Amazon Echo, which has Amazon Alexa inside it. And next is Google Home, which has Google Assistant as its virtual assistant. And Microsoft and Harman Kardon also has released its smart speaker. Harman Kardon developed its hardware, and Microsoft produced the Cortana as a virtual assistant. And this year, Apple has released Apple HomePod. And there are so much more other speakers all over the world. What I wanted to tell you is that we will use Google Home and Alexa today, but there are many other smart speakers all over the world, like Microsoft Cortana ones. So then let's move on Google Home with Azure Functions. I'll talk about how you can develop or extend your Google Home. Google Home speakers enable users to speak voice commands to interact with services through Google's intelligent person assistant called Google Assistant. In December 2016, Google launched Actions on Google, a developer platform for Google Assistant. Actions on Google allows third-party developers to build apps for Google Assistant. So if if we want our code runs on Google Homes, you have to develop here. You have to develop actions. This is an overview of how to extend functionalities of Google Assistant. As I said, you need to create an action to extend functionality of the Google Assistant. And Google has been providing the platform called Actions on Google to manage all actions. And this is how actions work. When you say a command which the Google Assistant already knows, like weather. Okay, Google, how is the weather like today?
Today in the city of Sydney, it'll be sunny with a forecast high of 66 and a low of 48. Right now it's 66.
Hi.
The mic's off.
Yeah, like this. So when you say a command which the Google Assistant already knows, what happened? The user says, how's the weather like in Sydney today? And the voice data sent to the Google Assistant, and it understands, oh, my master said, how's the weather like in Sydney today? It's text. Turn to text. And it also understands he or she seems to want to know how the weather is like in Sydney, so I'll call weather service. So it invokes the weather service. And the weather service returns a JSON data. And finally, it speaks, it's sunny today. It is how actions work. And then, on the other hand, what's going on when you say a command which the Google Assistant does not know? When you say connect to Hello Azure Functions service, and the voice data will send to the Google Assistant and Actions on Google, and it understands, oh, my master said connect to Hello Azure Functions service, it turns text. But it got confused. Hello Azure Functions service, I don't know such service. I searched all first-party and third-party service, but found nothing named Hello Azure Functions. So I don't know what to do. I'll bring you back an error message. So it brings back to error message, error. And finally, the devices says, I don't know what to do. So the main topic, how to create your action. You need to implement this function called fulfillment in Google Platform as Web API invoked by webhook. You can use any platforms like Microsoft Azure, Google Cloud Platform, Amazon Web Services, or on-premises. So let's get into demo. But before demo, let me explain how my demo works on its architecture first. My demo app, No Ops Manager v0.1, hopefully will work like this. When I say deploy Azure Functions to Japanese, and it invokes Azure, and it said I have triggered a deployment for deploy from Google Home. Please check the progress on Microsoft Azure, and you can check the Azure portal, and you can see the deployment is underway or the status. And what is Azure Functions? Functions is, this is my manga. Now we can use Azure Functions, a serverless compute service which enables you to run code on demand without having to explicitly provision or manage infrastructure. Difficult to pronounce for me. The architecture will like this. Deploy Azure Functions to Japanese, I said, and it's sent to Google Assistant, and and then next Google Dialogflow will invoked, and it detect intent, fill all slot, and invoke webhook. And Google Dialogflow says she wants to deploy Azure Functions to Japanese, so it understands the intent and entities like Japanese and Azure Functions. And also, I send these data to endpoint you gave me, so it invokes webhook. And Azure Function is called. Azure Functions says I ask Azure to deploy Azure Functions and its dependencies. And it invoked Azure, and Azure said, okay, I started deploying. Wait a few minutes, and also Azure Functions to also generate reply message saying, I have triggered a blah, blah, blah. And Google Home will say, I have triggered a deployment, blah, blah, blah. So I'll do some demo of it. What a night. Okay, it worked. Thank you. First, I will show the I'm so worried that my English pronunciation is not good, so I don't know whether if it can.
By the way,
oh.
it's off. Put it back on. Slide the switch on the back.
Okay.
The mic's back on.
Talk to my test app. Okay, Google. Talk to my test app.
Okay, let's get the test version of my test app. Welcome. I can help you deploy resources to Microsoft Azure. For example, deploy Azure Functions to Australia East.
Deploy Azure Functions to Japan East.
What is the resource group name?
Test LG.
What do you want to call your app?
Madoka Test 6.
I have triggered a deployment for deploy from Google Home 201,809,210,417. Please check the progress on the Microsoft Azure portal.
Okay, maybe. Thank you. I said resource group
I
name.
couldn't hear what you've just said. I have triggered a deployment for deploy from Google Home 201,809,210,417.
Okay, thank you.
Please check the progress on the Microsoft Azure portal.
Thank you.
You're welcome. Happy coding.
It got. I said test RG resource group, but it detects my pronunciation test AG. And I can see the deployments status, and it says deploying. Huh? What happened? I see. I'm so nervous now. And maybe it works well. So I'd like to show you the Dialogflow, which is a natural language service provided by Google. So I registered some intent. The default intent is also called welcome intent. Welcome intent is when the action was called, it is always invoked, and it says like this: welcome, I can help you deploy resources to Microsoft Azure, for example. And I also registered another intent, deploy intent. Deploy Azure Functions to Japan East. It is entities, and I registered some entities named region name. Japan East, Japan West, Australia East, Australia Southeast. Maybe I must all region name here, but for now I just registered for entities. And the last entity is finish intent. You must register finish intent to publish your skill or action. Finish intent is when you want to finish or kill the skill, you have to register. And it says, "You're welcome, happy coding." I registered. When I say thanks or thank you, it will die. It will finish. My English vocabulary is not good. So, and also it has a simulator. When I developed this skill, my English pronunciation is not good, so I always use this simulator. You can also use this simulator too. For example, cancel. Talk to my test app. And its response is like this, and you can also use the debugger. When the request does not have all required parameters like region name or app name, you will be. Maybe you can read the code. Sorry. Here. Deploy Azure Functions to Japan East. And here, it stops here. So you can develop the application. So I will go back to my slide. Maybe it works well. And let me introduce a little about Azure Functions. Azure Functions supports a lot of bindings. Plus, you can also your own custom bindings. So, Azure Functions supports bindings. It means that you don't need to write a lot of code for connecting other services like Cosmos DB or Event Hubs or storage queues and so on. It helps you to reduce your code and focus on business logic. Also, as I said, you can develop your custom binding by yourself. For this demo, I used a custom bindings which enables you to deploy every resources on Azure from your Azure Functions. This time I'm using ARM template. ARM template means Azure Resource Manager template, custom template developed by Tsuyoshi Ushio, my colleague, and sitting over there, developed. And do you want to? No? Okay, but ARM template enables us to deploy any Azure resources from Azure Functions without writing a lot of code, like authentication, client, and so on. all you need to do is specify your ARM template and specify the parameters. This is the how to code sample code. And you can see my code too. In Visual Studio. This line says detect my Azure resources, like client ID, client path, tenant ID. And when you deploy resources to Azure, you just write this code, maybe one line. So you specify the deploy name and template name and path parameter and location and so on. Just this, and maybe my part will be finished. Thank you. Thank you. Thank you. Thank you.
And so that was a pretty amazing Google Home demo, and using Azure Functions and so forth as well. And I guess one of the key highlights from Madoka's part was how you can use sort of the Google Assistant services, build your own custom model, and sort of use some of those features as well. And so if I just quickly get to switch back to my slides, what you'll notice also is that I've got a Alexa device here. So again, these devices are pretty cheap, both of them, so you can kind of start experimenting at home directly. So there's one option of using that, but in my case, what I've done is I've simply used my existing bot that I had built for Azure, which, for example, is over here, hosted and built. So I took one of my existing bots that I showed yesterday while I was doing some introductory pieces, some of the new SDK, which is just a simple echo bot. But again, I can replace this with anything more complex as well. All I did was hosted this. You can host this any way you want. I just hosted on Azure. It's a simple web service, so nothing fancy there. But on the other hand, there's also a pretty interesting open source project which allows you to build a bridge between Alexa and the Microsoft bot SDK as well. So it allows you to kind of use that directly. And just by making a couple of changes, I ended up just using the same SDK, again, hosting that on Azure, or sorry about the dark themes, or you could also even kind of use it directly by setting up a webhook or setting up a secure tunnel between your machine and the portal as well. So once I had set up this infrastructure, which has my bot code, has this Alexa bridge running, which effectively is waiting for Alexa to talk to it, the next step was to sign up to the Amazon Alexa Skills Dev Kit, as they call it. So one of the interesting elements there is that I can literally go off, create a new skill. So in my case, I called it that, gave it a nice logo to begin with. And after I did that, the only thing that's kind of different from what Madoka did with the Google skill was that I've got a very, very simple sort of description here that I've given to my actual intents here, to my actual intent engine here. So what I've done is, instead of using any of the pre-built intents that Amazon has or any of the existing ones or building any new ones, I've simply built a intent here which says get user intent, which effectively means that everything that a user says onto my device, just send that through directly to my web service, and it will do the rest of the job. So there are easier ways to work around this, and again, you can do the same thing with the sort of Cortana counterpart as well if you like. So you can build a skill which effectively is using some other NLP engines as well. So nothing different there. Then I went in there, defined my endpoint for the bridge that I had sort of grabbed from the open source project. And once I did that, I tested it a few times and then distributed it through the console itself. And I've got that in here. So if I simply, again, I was looking for a unique name, so I just went with Donbury's because that's what I like. And I just found the Japanese name for it. So if I just open up my Alexa device here and say, hey, Alexa, ask Boru how's it going.
Working in it. You sent how's it going?
Cool. And so that's effectively the whole transmission that's sort of taken place from the Alexa over here, then talking it all the way to the Alexa skill that I had built, then sort of talking it to my middleware, which effectively had the infrastructure to communicate between the Alexa and my bot sitting in Azure, and all using this really simple boilerplate code, which effectively builds an adapter on top of our existing framework. So fairly easy to set up as well. And the really big key difference there is effectively setting up your skill in a way that allows you to really pass through every single utterance that comes from the user that I specified here, and directly sending it to the web service behind the scenes to take care of all the other elements behind it. And so if I had to just quickly kind of walk through that itself, I've literally got 3 moving parts there, one of them being my actual bot code, so you can bring in whichever bot you like. The other one being the bot service, which kind of hosts my bot communication channels, and then using the Alexa bridge against it as well. So fairly easy to do. But in summary, I guess it's really about understanding how these speaker devices and the speech technology is becoming a lot more accessible. It's fairly cheap and easy to kind of buy and start consuming, but at the same time building for them as well. As you thrust throughout the session, we talked a little bit about what are the different elements of analyzing speech. Then we looked into how easy or difficult it is to actually build some of those skills, or even invest in one place with a single technology, and then start sort of combining other personal assistants and devices as well through the similar platform itself. So I guess in summary, what Madoka and I would probably kind of say is that really about understanding, if there's any sort of sufficient technology that's out there, it becomes, first of all, indistinguishable from magic, but at the same time, it potentially disappears as well. And that's the sort of what outlook we're looking at through speech across all of those different devices and technologies. So with that, thank you.
Thank you.
And I think we've got about 5 or 6 minutes. Any questions, anyone? You can come and talk to us later as well. Cool, thanks.